Welcome everyone on another 3Shape webinar. I hope everyone can hear me loud and clearly. And today's topic is copings. My name is Christopher Adamus, for the ones that don't know me yet, because maybe you're joining for our first time on this webinar. I'm a dental technician and dental application specialist for 3Shape Academy for just over 4 years. Previously, I've spent just over 5 years in a milling center, working primarily on the 3Shape scanners. I would like to remind you, obviously, for the ones that are joining and are not familiar with this concept, that you can ask the questions using chat or question mode, and I will get back to you at the end of this session with some answers, of course, if I will be capable of answering them right away. And since you're joining on this webinar, it means that you're subscribing for 3Shape software, so you're covered with a LabCare. LabCare is a program that we are offering to all our subscribers. It's free of charge, of course, as long as you're subscribing. And what we are offering is trainings, upgrades, and the support for all of you. So as an expert training, you can participate in hands-on trainings, webinars, and you will have an access to a download center where you can download more materials, videos, and learning material. You have also access to technical support, not only the online as a software support, but also you can use a hardware service and use any of five of them available worldwide in different places around the world. Of course, the ones of you that are using 3Shape software for a long time probably know exactly that you can all of the updates of the software which are coming throughout the year, they are coming free of charge. And of course, one big annual release will also be included, and it's also free of charge, and all of the live subscribers are entitled to get one. So what's on today's agenda? First, I will get through the creating of the order form. That is childishly easy, and it's one of the most basic indications you can imagine for CAD/CAM software. Then I will get through the scanning of a single die, since I've prepared a scanner. There's one behind me ready to scan. I will also show you what's the quickest way of to scan a single die, and maybe I'll even prove to you that it can be done in less than a minute, and since we are showing that the software that we are using is very quick. So we will make a quick scan of a single die, and then I'll also get you through some of the design. So we will design a single coping. I'll show you what kind of functionalities you can find and how to use a help function at the same time. And at the end, I'll also show you where to find settings in the control panel, how to predefine the settings for the copings right away, so there's no need for any additional adjustments of the settings during the design itself. Okay, so at first, of course, I will open Dental Manager. Mind you that I'm working on a Dental System 2016 as a pre-release prototype, so there might be some small differences in the software from my software to your software, but it should be more of a minor changes. So first, what I will do is I will click on the new order form on the top left side of the screen, and that should open a new order form. Okay, good. From here, I will select what I would like to design. I've prepared myself a coping for a tooth 2-1, so I will highlight this one, and as long as we can see this red outline of the preparation, this item is an active one. Copings we will find in the frame stage, and we have two copings in here. We have anatomical copings and we have a standard coping. Today I will focus on the standard coping as anatomical coping is basically a variation of a full contour crown. Anatomical coping is a concept of a cutback crown. So during the design, we would work with a full anatomical restoration and then make a cutback to it. I will show you this one a little bit later on. I will start with a simple coping in zirconia. Why not? We can use this one as a material. So to make a very quick scan, the quickest one possible, I will use, of course, model as my object, and I'm not going to use antagonist. We take under consideration a scenario where we need to make just a quick cap over the preparation. And when it comes to the neighboring scan, since I don't want to scan a full arch, I want to make a quick scan, I will select none. And this setup will allow me to make a very quick scan of just a single die, nothing else. Of course, if you are making anatomical coping, that's not going to be possible. You need to have at least neighboring teeth scans, so software will still ask you for neighboring models. So this is a pretty specific scenario, just a simple 0.35 to 5.5 millimeter coping on top of the preparation, nothing else. Okay, from here, directly, from the order form, we can go directly into the scanning software. And you can see at the bottom of the screen, I have an option to click OK, so to save my order form for later, or we can go directly to the scanning mode, and that will make the software start up the scanning software. My scanner is already running in the background, so right now I will focus on what's on the screen. So I can place my die on the black tray that you should have somewhere around you, and of course there's a piece of a blue tack in the very center of it, so we can place it in the center of the focus for the cameras. If you have a multi-die fixture, you can also use the center of the multi-die fixture as well and place it over there. Let me see if I can engage the camera here. Yeah, so now you should also see me on the camera on the side. And yeah, what I will do is I will just place a single die. I have a die in here with a pretty long pins at the bottom. So what I will do is I'll try to secure it by making this blue tack stump a little bit higher and covering slightly the sides of the prep. A small hint, try to keep the margin line parallel to the base of the scanning tray. That will make it possible of scanning it quickly and without any need of any rescanning, and all of the prep should be visible right away. So what I will do from here is I will open the scanner, place the die inside. When it comes to rotation of it, it doesn't really matter how it's going to be rotated. I'm usually placing it with the buckle side facing inside the scanner, as it's the easiest to match it afterwards if we will scan a bigger model. Okay, then I can click next and software will start scanning. And here we're using a new software, so Scan It Dental, not Scan It Restoration. But in here the differences are rather small, especially for a case like this. So as you can hear, the scanner is working and it already receives the data from the scan. As long as the die is fixed securely, you will have a good and sharp image and the data, and then a few seconds later software will combine all the surfaces into our die. And as you can see, everything was scanned nicely. The die is the scanning process is completed and saved. So from here we can go directly into the designing part. That will of course shut down the scanning mode, but it will open Dental Designer. So from here, of course, we need to mark the annotation always do it on the buckle side, always close to the margin line, as it makes it the easiest for the future processes for the designing purpose. From here, software will suggest the insertion direction. I can verify it and check if software found the correct one. Of course, this is a pretty nice prep. If we have more difficult ones, it might be more difficult to also find a good insertion path. I can see that there are some green dots. They are highlighting the areas where software think that the margin should be. If it's placed correctly, then it's fine. Of course, you can change the insertion path by choosing a different angle on the screen. So imagine that you're looking at a die from the top and trying to find the perfect insertion direction. And then you can press Set to lock the new insertion path proposal. That's nice. I've managed to find a position where there's absolutely no undercuts on the top cap. There are some slight undercuts below the margin line, but I don't worry about them. If you will have some small undercuts on the preparation, also there's no need to panic as long as they're not crossing the margin line. They will be blocked out automatically by the software. You can also change the possible insertion directions using the vectors, the arrows on the side. So if we would have an undercut like this one, because it's not crossing the margin line, it will not affect the fitting of the case, so no need to worry about that. Okay, but since we have a better position, I will use this one. And from here, I will click Next. Software will try to draw the margin line. And if it's a margin line that you're happy with, you can, of course, leave it. If not, click on the left mouse button in the place where you want margin to be adjusted to. And that's the general rule, and that applies to dental system. So don't try to push it somewhere, because that's not going to work. Show where you want margin to be. If you want to make a bigger changes, press and hold left mouse button and redraw the margin line. If something goes terribly wrong because you're using other system and you mix left and right mouse button, you can always undo the previous movement. In here, I also need to introduce you to a hotkey on the keyboard. It's button F, which stands for Fast Edit. By default, this option is enabled. That's why we don't see this points all the time. But if you find it easier to adjust the margin line using point options, of course, you can just click on the button F, and that will enable the point distance, points on the margin line. We can also determine the point distance in here in the advanced menu options. So as smaller the distance, as more denser placement of the dots will be. Ooh. No, F is not a very good value here. 0.320, I think. That was the one that we managed to get. Yep. Some of you might be curious, what is the angle? Well, if I'll show the angle graphics, maybe that will make it easier. This is basically an indication on where on the surface the margin line is placed. So you can see exactly the curvature in which the software placed the margin on. Some of you might want to place the margin to be entirely parallel. Well, it sounds like a good idea, but it might be difficult to fit the coping, especially if it's going to be in zirconia. It's going to be harder than a gypsum model that we have in here, and that might actually chip slightly the edge of the coping. So in here we can quite clearly see where it is, each of the points is placed on the surface of the skin with a high magnification. Because they're resting a little bit on top of the surface, that should actually give a very good result. And since we're working with a big magnification in here on the CAD software, you will see that actually the margin line is not super sharp, and it's not because the scanner is not showing it sharp. No, this is how it looks on the model, so this is as sharp as the model is. We have also an option to either maintain the angle or provide more smoothing of the margin line. You can adjust those line and see how the margin line is changing. Personally, I prefer to have it in here around 15-degree angle. That usually finds a very good resting position for the die, a very good fitting without compromising the quality. We can also define individual insertion direction, and here it would make sense to use it mostly for the bridges, not for the single copings, so there's no need to worry about that. And we can also show the surface noise. In here we don't see any surface noise, and we won't see it because it's a gypsum scan. If it would be scanned from intraocular scanners, then we might see some areas which haven't been scanned with enough, let's say, precision or quality. Okay, if I'll click preview, software will show me which area will be covered with the coping, and going to the next stage, I'll be able to put die interface, which is nothing else than just a cement spacer. And here we have quite a few values that are determining our coping values, the cement spacer values. If you are wondering what exactly those numbers mean, I would recommend you to press F1. That will get you to a manual. Manual is integrated with dental system, so wherever you're going to get lost within a dental system, pressing F1 will get you to the chapter that it's related to what you have currently on the screen. So as you can see, it got me to single coping design, and step 5, apply die interface. And here we have an information about the undercuts and also clear explanation of different values that we will get in here. So of course, if you would like to know more, please go ahead, look through it, and try to find the optimal settings for yourself. Okay, so in here, what I will do is I'll click preview, where software will apply the cement spacer for me. Just as a quick explanation, I will tell you that we usually apply the cement spacer in 2 values, one very, very thin, close to the margin line to ensure the maximum precision and fitting of the coping. Then we're placing a slightly higher value where we provide the actual cement spacer. In this case, because we have a very sharp edge, we also added a little bit space to compensate for the size of the drill, to make sure that the coping will fit on the preparation and in the patient mouth afterwards precisely. Okay, then software will apply just a simple coping values. If I will open the coping menu on the left-hand side menu, so just in here, you can see that I have different options for different types of the copings. I applied zirconia settings. So in here we have information about the coping itself. So what will be the thickness of the material, and what will be the edge settings as well. Of course, that will define a lot on the material that you're using and the manufacturing process. These values, of course, can be adjusted if you know that your machine can mill very precisely and the tools are sharp. Maybe we could lower the values and make the edge a little bit smaller. From here we have also a very simple tool to apply the lingual band. If I'll just use the tick box option, you will see the start and the finishing of my lingual band. Every time you want to see some changes to the design, you need to click preview, and software will actually build a lingual band in between those 2 dots. Of course, you can change the position of them, changing the starting and finishing angle, and since it's an angle, it should be pretty self-explanatory that this angle is calculated according to the buckle dot, this annotation that we placed on the buckle side. So from here, 120 degrees further, our lingual band will start, 240 degree will finish, and of course it will end at the front. Some people like to make 360-degree bands. That's not a problem. Let me make it just a little bit smaller, as this one would be pretty big. And if I'll put it from 0 to 360, click preview, you can see that we have a very nice margin, the lingual band all the way around, so it's like 360 margin. If you would be making this coping in metal, some of you need it to be like this. So there you go, very easy functionality. And then, of course, we can also change the angle of this lingual band. It's predefined in offset angle. Let me put it back as a 1 millimeter, so it's going to be easier for me to show you. Oh, in here, if I will change the angle to a slightly bigger one, you will see that it's going to be more vertical, and if I will change it the other way around, it's going to be more flat. It's a very simple one, since we're not relying on the full anatomy. And of course, I don't have any neighboring scans, so I shouldn't be making any build-ups in here. Of course, if you feel very confident, you can use some of the tools in here to make maybe a small build-up, improvise for the shape. And of course, you can also use some of the visibility sliders in here to check the thickness of the coping in different places. So since we need 0.6 millimeters, you can see that all the green areas will be 0.6. In here, since I've made some build-up, it will be bigger. Okay, so from here, as you can see, a very simple design would go next, and software will save my design, and job is ready to be sent for manufacturing. If we have external manufacturer, of course, it would have to be sent externally. If we keep it in-house, then of course it will be saved locally. So here is my design. If you predefine also that you are the manufacturer, then most probably you will be able to also export a file that could be used locally. In this case, I've saved my design as an STL file, so I could use it locally in my in-house milling machine quite easily as well. Okay, I also promised to show you where to find the coping settings in the control panel. So let me go back to control panel and show you the copings option in frame elements. In copings, we have a big table of different parameters. Some of them, of course, are explained in here. Some of them you will find also in the manual. So if I will press F1, you can see that gets me to a different part. This is a coping section in the control panel. So in the page called How Do I Configure, and in here we have information about some of those parameters in here as well. Changing parameters in this page will change the default parameters used during the design. So of course, whenever you will select the coping from Zirconia, these settings will be applied. If you would like to create your own material, I usually recommend to copy the material, and based on the copy, then make changes. And of course, save it and use it afterwards for the next case. Okay. As I told you, there's also a possibility of using making a copings as an anatomical option, so anatomical copings. And for this, we need to define the order form in a slightly different way. In this case, I will take first molar. and choose second option, so anatomical coping. This option will make outside-in design, so I will start from a crown and then make a reduction to a coping. In here, I need to have at least neighboring scan. Probably antagonist will be used, would be useful as well, since we're making a cutback. It would be good to know how much buildup we would have to make afterwards. In this case, I will not make a scan. I will just import the scan just to save some time, as we have only a couple of minutes left. Of course, the full scanning procedure was explained in the other webinar, so I would refer you to this one to get more information on the scanning process. So how the design will look. The first stages will be very similar to what you've seen so far. If there was an annotation made during the scanning process, then of course you don't need to do it during the design. So the first step, defining the insertion direction. This is something that we've been through with a single coping, so that should be easy enough. The same as defining the margin line and applying the cement spacer. After this step, you might notice some differences, because in the workflow right now I will see the full anatomy, so I'll work with the full anatomy first, try to place it correctly and make the good full contour design, good proposal for a final restoration. And based on this one, so based on full anatomy, we will make a cutback exactly with the amount of material that we would like to apply for final restoration. And here it makes sense to use sculpt tools more extensively. Also, make sure that the design is not colliding with the antagonist. So we can cut it to antagonist right away. We can also, if you would like to go even further with the design, use a virtual articulator. And make sure that our full contour design is not colliding during the full articulation movement. Okay, let's take a look. Don't see any color spots, so there should be no need for any serious adaptation. I can see that option adapt design is disabled, so there should be no collisions during the articulation for this restoration. And then the actual cutback will appear. So during the next stage, where we will be working on the frame design, software will make a cutback to the current design. So what we can do is we can predefine the optimum amount of either ceramic or composite that we would like to apply, and software will try to enforce it and make a cutback. Of course, more important is to keep the minimum thickness of the coping over there. So if there's not enough space for the cutback, that would be respected more. Thickness of the coping will be more important than the thickness of the ceramic. Okay, even if something like this happens, so software freezes for no apparent reason, there's no need to panic. Most of my design should be saved, and software have an auto-saving feature included, so it saves every 5 minutes on the progress of your case. So even if you're working with a big case, then the most that you will lose is the last 5 minutes of your design. So let me try to get to the process where we finished and see if we can complete this one. Right, I can see that software remembered the whole process up to full anatomy, and now it just recalculates all the procedures that I've done so far. So you can see it haven't saved everything, so I'll try to make enforce the auto placement first. Make sure that it fits into in the bite. It looks like it is. So let me try to get to the next stage. And there you go. I can see that the progress bar is moving, so software is trying to move further. It's interesting. It seems like enforcing minimum thickness in here brings some problems. That could be related. Well, could be. I'm pretty sure that it's related to the version of the software that I'm using. So pre-release version, and I can see that it's stalling my computer really badly. I seriously apologize for this not very smooth workflow for anatomical coping, but I believe that it's just a version of the software, so not fully released one as the one that brings the problems here. Right. This time I'll try not to reinforce minimum thickness, as it's not mandatory for this type of restoration, at least on this stage. On the next stage, on the coping stage, of course, it will be mandatory, and here not so much. And voila. So software made a cutback. In this case, it was a cutback of 0.8 millimeters. Of course, making sure that the minimum thickness of the coping of 0.6 is capped. So you can see that there's a uniform offset all the way around. If you would like to make a different offsets in different surfaces, it's just a matter of unticking the applying uniform offset, recalculating the new values to show how the framework would look like. In this case, we can also make a small backings, just like I showed you with the lingual bands on the simple coping. In here, it looks a little bit different. We're using the full anatomy as an initial surface for creating a backing. And if I will move it just by pressing and holding left mouse button, this line a little bit higher, and of course clicking preview to update the preview, that will give us a new result. So right now, if I will take off my full anatomy preview, you can see that we have a very nice backing in here on this molar. Of course, using the same rules, I can move this line further and higher and make, for instance, a cutback, creating a 3/4 crown or a crown for buccal veneering. So it's also type of a coping, since we have a cutback. If I will click initialize, everything will go back to the initial position, so 0.2 millimeter margin all the way around. If you prefer to use brush option, there's a paint mode where we can highlight which areas we would like to keep. So do not apply any cutbacks. And if I will press the shift button and use the wheel on the mouse, I can select the size of the tool for highlighting smaller or bigger areas of the cutback. And then of course click preview to update the information here. Okay, I hope that this information is rather clear. We have also option for occlusal stop, so if there's any areas in the occlusal surface that you think is going to be too thin, there's not going to be enough space for the ceramic, you can also highlight them and as a simple shape and save them from the full anatomy design. So in here, I wanted to show you the second type of the coping, anatomical coping. I hope that that was simple enough. Let me take a quick look if there's any questions coming out from you guys. I can see that there's no questions coming up so far. So I guess that this session was really simple. I will be here for the next couple of minutes, so if you will come up with some questions, please send them over and I will try to reply on them right away. If not, you can also use our email, that's webinar@3shape.com, and you can send your questions regarding this or other webinars directly over there. Okay, so thank you very much for joining us today. I hope that you found this session informative. And of course, I would like to invite you to join us in the future. Thank you very much. Have a nice day.